Imagine for a second giving a digital voice to a language that's completely silent. It sounds like something out of a sci-fi movie, right? But it's not. It's a real technological breakthrough, and that's what we're going to dive into today. And trust me, this is way more than just some new app. It's a serious effort to close one of the biggest gaps we have in human communication.
Okay, to really get a handle on why this matters, look at this number, 2.6 million. And that's not just some abstract statistic. We're talking about 2.6 million people, just in Bangladesh, who use sign language as their primary way of communicating, every single day. For them, something as simple as a regular conversation can be a massive hurdle. So, this all leads to the big question, really the core idea behind this whole project. What if technology could do more than just translate Spanish to English? What if it could actually translate between the spoken word and the visual world of sign language instantly? That's the incredible promise we're looking at here.
All right, so here's our game plan. We're going to start with the communication barrier itself, then get into the weeds of the Bangla language challenge. After that, we'll look at the digital voice they created, see how it actually performs, and wrap up by thinking about how this could seriously bridge the digital divide.
So let's kick things off. For millions of people, Bangla Sign Language, or BSDL as it's known, isn't just something they learned. It's their first language. It's how they argue, joke, share ideas, live their lives. But here's the kicker. Almost nobody outside of the deaf community can understand it. It's like a wall between worlds.
And this isn't just a local problem in Bangladesh. No way. It is a global issue. Just look at this quote. It says that only about 5% of people worldwide can communicate using sign language. Let that sink in for a second. 5%. That means 95% of us are completely cut off from these conversations. And that creates this incredible sense of isolation for so many people.
All right, moving on. Now you might be thinking, if this is such a big problem, why hasn't someone just built a translator? Well, it turns out it's incredibly difficult. If it were easy, it would have been done ages ago. Researchers ran into some major roadblocks, especially with a language as rich and nuanced as Bangla.
So, what were these hurdles? Well, for starters, Bangla itself is a really complex language with a ton of regional differences. Then there was a huge problem. There was practically no digital data for Bangla Sign Language to train an AI on. You can't build it if you have nothing to teach it with. On top of that, sign languages have their own super intricate grammar. It's all about hand shape, where you place it, how you move it. And the final piece, which is so important, is capturing those subtle things like facial expressions. A raised eyebrow can literally change the entire meaning of a sentence.
So that brings us to the breakthrough. Now, despite all those massive challenges, a team of researchers pulled off something amazing. They actually built a system that can take spoken or written Bangla and translate it right then and there into 3D animated sign language. And it's all performed by a digital avatar. And let's be super clear about this. This is a big deal. We're talking about the first ever complete system that can do this. Go from Bangla text or voice all the way to a dynamic 3D animated sign. It's a genuine milestone in this field. Okay, so you're probably wondering, how on earth does this actually work? I mean, how do you take a sound or a sentence and turn it into a physical, understandable gesture? Well, the magic is really built on two key pieces of tech.
Okay, the first piece of this puzzle has a technical name, HamNoSys. But don't worry about the name. The best way to think about it is like musical notes, but for sign language. It's basically a universal code that lets you write down a gesture. Every little detail, like the hand shape, where it's pointing, how it moves, all in a way a computer can actually read and process.
So if HamNoSys is the musical notes, then the next part, SiGML, is basically the sheet music. It takes all those individual notes and organizes them into a full performance script that the 3D avatar can follow. It's the final set of instructions. And using these standardized systems is so important because it means this isn't some one-time trick. It's a method that could be repeated and scaled up.
So let's walk through the whole translation process. It's actually pretty straightforward. Step 1. You speak or type something in Bangla. Step 2. The system grabs that input and breaks it down. Step 3. It looks up the sheet music, that SiGML file, for each of those pieces. And finally, Step 4. It sends that script to the 3D avatar, and boom, it performs the signs.
Okay, but here's a smart question. What happens if you type a word this system has never seen before? Does it just crash? No. It has this really clever fallback. It automatically switches to fingerspelling. It just spells the word out, letter by letter. This is huge because it means communication never breaks down.
Nothing gets lost in translation.
All right, so the idea is brilliant, but this is the moment of truth, right? How well does it actually work? Is it accurate? Is it fast enough to even be useful in a real conversation?
Well, the results are actually pretty incredible. When you feed it text, it's 97.5% accurate. That's amazing. But even for the much harder job of understanding spoken words, it still pulls off a 94.75% accuracy rate. I mean, those are some seriously solid numbers.
And get this, it's not just accurate, it's fast. We're talking an average processing time of less than 80 milliseconds. That's faster than the blink of an eye. And that speed is what makes it practical. It's fast enough for a real-time conversation, which is the whole point, right? It has to be useful in the real world.
Okay, so let's move on to our final section. We know the tech works, and we know it's fast. But let's zoom out. What does something like this really mean for people's lives? Where could this tech make a real difference?
Honestly, the possibilities here are huge. Just think about it. In a classroom, this could be an amazing interactive learning tool. In a hospital, a doctor could finally communicate clearly with a deaf patient, no interpreter needed. We're talking about everything from public service announcements to legal meetings. This kind of tech could truly empower people and create a whole new level of independence and accessibility. This quote from the researchers really sums it all up.
Yeah, the wording deaf and normal people is a bit old-fashioned, but the intention behind it is crystal clear. Their goal was to use this technology to tear down the wall between the deaf and hearing worlds and just let people communicate seamlessly. And that really leaves us with one last massive question to think about. There are over 200 different sign languages used around the globe. So if this model, this approach, can work for a language as complex and nuanced as Bangla, just imagine, what's stopping us from adapting this to help bridge communication gaps for all those other sign languages and finally connect millions more people all over the world?